Alright, so today we're going to be doing a video. We're going to begin making a vaporizer for the truck using these vaporizers. This is a Type C input. Let me show you that. It's a Type C input. We can get the camera to focus here. So you have a Type C input, which is what you'd use on Android cell phones, the newer style ones. And then you've got your wick, which is what this is, and your atomizer. These atomizers, it's kind of a new style. I haven't seen these before, so I figured I'd try it out. And I did try one of these, and I was really impressed at how much vapor they put out and the size of the droplets. The molecules are very small. They float, and that's what you're looking for. You're looking for, the idea behind this vaporizer for the truck is to pick up water vapor mixed with hydrogen and really active molecules. So whether that's high voltage or different things. But anyway, we're going to experiment with that. But the water vapor mixed with the hydrogen will cause the engine to run cooler and stronger. It's going to add horsepower, and it's also going to cool the combustion chamber, which will keep the engine running cooler as we turn the fuel down. So that's the idea behind the water vaporizer. So we've got these modules. They sit inside this cap, and the wick actually pulls water up. Let me get my finger out of the way here. That's hard to do. So let me get one of these out of here. Alright, the first thing we're going to do is put this together and test it out, see how it works, and then we're going to make this operate with 6 of these around this float. This float is going to be inside the vapor chamber. This is the water input, and you can see how the float works. And also, the float is adjustable. I mean, it's pretty coarse adjustment. It'll be about right there. Well, anyway, about like that. But this water input, supply pressure here. Anytime this level drops, water will be added until it shuts it back off again. Okay, so these are going to be placed alongside 1, 2, 3 on each side, and I'm hoping that is going to be enough water vapor to operate efficiently with the amount of volume that the motor is pulling in. Volume of air, I mean. So actually we have quite a long, we have about a foot of wire here from the vaporizer to the circuit board, which is good because it gives us the ability to move the circuit board outside of our chamber, which was an issue. I was thinking about putting this circuit board inside of the float. Now, not having to modify the float would be nice, because we don't want to mess with the integrity of the float. And water, being a vapor, can fall back inside and fill the float up and cause it to not open or stay open and flood. And that's another thing we want to try to prevent that for sure. We don't want water flowing directly into our engine. So water vapor is good, straight water bad. So anyway, we have a lot of room to move this outside of our vapor chamber. The only problem, the only real issue I have with this, let me get this light in here so you can see. The only real issue I have is these switches on the circuit board. So in order to activate this, you have to push a switch. Now I don't know which ones do what or what they do exactly, but I can tell that there are 3 position switches because they have 4 solder tabs. So that means there's 1 input, 3 different outputs, and there's 2 switches. So this may be run on 2 banks of 3 with each switch. I'm not sure. So we'll find that out. I'm going to go ahead and put this together, put these together, and hook everything up, and then drop these into some water and try to operate this board. By the way, this is a Type-C DC 5-volt DIY ultrasonic mist maker 6-channel atomizing module humidifier off of eBay, and I paid about 13 bucks for it. I don't see any more on eBay right now, but you could find it. It's a 6-output ultrasonic mist maker, 6-channel. So you know, if you're looking to make a lot of fog, this is going to do it. And if you don't need remote control, which we will, you can push the buttons on the board. You can put this board somewhere where you can get to the buttons, but for me that's going to be an impossibility. For me, this is going to have to go, this power input is going to have to be the on-off switch. So when power is applied, this will automatically be on, and it'll be on until you shut power off. So that's how we're going to make this board work. But first we're going to find out what these buttons do, how this operates, whether or not we can control variability, because I'd like to be able to do that on the truck. I don't want to just do 6 vaporizers and hope that that's going to be the right amount of vapor. That should vary. It should vary by load. You know, at idle I don't want all 6 operating. At idle I'm not going to need that. You know, and I definitely don't want to be quenching a flame in the combustion chamber. So anyway, let's get to it. So first thing I'm going to do, I'm going to take this one apart. So these caps, I'm going to take that out. These caps snap together. I don't know if I can see. You see one part fits over the other part, and it just snaps. It'll be easier to show you snapping it. Let me get something here. Pry that up. So these little tabs lock the 2 parts together. So you have to separate the tabs and pull that apart. Okay. Heard a satisfying snap. Do that on the other side. This one here. Oh, there we go. Okay. So you can see you've got 2 halves that snap together. One of these halves has, I don't know if you can tell from that angle, yeah, so you can kind of see there. You can see this little cutout, and if I put the other piece up against it, you'll see that that leaves a gap, and that gap is where you're going to have your wire coming out. So the wire will sit, so this sits like this, and the wire will sit in that gap, and the other piece will go over it. Now also there's an up and down on these. There's a indentation and a bump out. Really hard for the camera to want to focus, but you can see a bump out there and an indentation on the other side. Maybe it's easier to see over here. I'm not sure if you can see that. So the indentation, I believe, goes up, but I need to verify that. There's already one that I've put together from a different kit. This is basically the same thing. It's just that these wires are shorter. This is larger, but it looks like I have the indentation down. Okay, so that's how we're going to do this one, and we'll test that before we go ahead and put all the rest of them together. So I'm going to just put one together here. So we slide the, by the way, this atomizer, and there's two wires soldered to it. You have the indentations, and then it has a rubber silicone sleeve that goes around it, and that silicone sleeve is like a damper. It allows the, I think, and I'm postulating here, I think that it allows the vibration, which I think is 100 kHz, the vibration to atomize water. And that bump out at the bottom actually sits against the end of our wick. This is a hard, like fiberglass material, but when it's put in water, water travels up it like a wick. And at the very top, that bump hits the wick inside here. If this isn't touching the vaporizer, the vaporizer won't put out any vapor. So as you can see that I'm going to try to show how I'm putting this together, and then we'll do all the rest of them the same way. So you got this piece, you got your vaporizer in there, and you got the other piece, and you just snap that on. Make sure your wire's loose, so you can see now how the wire comes through that little gap, and you can see the vaporizer inside, and we have the bump up facing down, and that's going to put it right on this. So when I slide this in, touches the vaporizer, it's right up against it. I don't have to force it in. It's a nice tight fit. It stays put. It stays in place. Then we're going to take that, drop that into our water container, which we'll leave over here. Okay, and then we'll just have that sitting there. And I'm going to use this to test various outputs on the board. So the first one I'm going to do is this one. That didn't want to stay there, so I've just got it pushed on enough to where I can pull it off easily. Now I'm going to go ahead and run power to it. This is just a Type-C cell phone Android plug. It's the same one I use for charging my phone. I'm going to go ahead and plug that into here, and that's going to give us power. Alright, you need to stay put, mister. Okay, and now, so we should have power. So if it's two banks, I'm going to go ahead and press the first button, which will be on this bank. See what happens. Nothing, nothing, nothing. Alright, I'll press the other button. Okay, something happened there. Okay, there's lights. Lights. Okay, there's our vapor. Now that's pretty good vapor. So I think what had happened is the vaporizer had fallen over into the water. It got wet, and it took it a minute to blast off the excess water on top of the vaporizer. But now that is putting out a tremendous amount. Let me try to zoom you out here, or raise you up, not sure which, so that you can see. Yeah, that's a lot of vapor. That is a lot of vapor. Okay, now I'm going to try this other button. Okay, so what that does, that position causes different activations, multiple different activations. So it shuts it off and on, but it moves. It actually, you can see when the lights light up, there is power to that output. So that's one way. It looks like it leaves 3 on at a time, and it varies back and forth along them. So that would be a way to vary the amount of vapor in the chamber. So let's say that would be a good idle circuit. Now the next one we're going to try, that turns on 1. I don't know if that's on a timer circuit or not. We'll see. But so far it looks like it's just turning on 1. We'll press it again. 2. Press it again. 3, 4, 5, 6. So this board has the ability to vary output 3 at a time throughout all 6, but with 3 on and off, on and off, on and off for a couple of seconds. We could time it, but I don't need to. Or you have the ability to turn on 1 at a time, or all 6 at the same time, by using this button. Okay, so next I'm going to go ahead and hit this button again. That's the on-off button, apparently. On. I guess the first position is all on. Off. So our first button here is our on-off button. That's all it does. The circuit resets itself to default with all 6 on. So if I turn this button on, all 6 are on. Now if I want to switch to varied output, like this is, where you have 3 on and they pulse back and forth along all 3, or I can go to 1, 2, 3, 4, 5, 6 and have all 6 on, or just 1 on. So I like this, but I don't like that it's right here. The on-off, we could modify that, or bypass it. That's simple. All we need for that is a jumper. We would have to take the switch out, but but basically what you need is just a jumper, which is just a small coated copper wire made for circuit boards that fits in a lug, and you just solder it in place. It's already tinned for solder. We could do that on this switch, and then this switch, I'm not sure. It's just a momentary switch. I'm not sure, but I need to be able to remotely press this button or remotely activate a similar button from inside the truck while I'm driving. Part of this vaporizer is going to be doing testing, readjusting fuel, and you know, whatever needs to be done to get the best mileage and to make the truck run the best. It's a diesel engine, 7.3 IDI, so there's no turbo, so the air coming in will pick up the vapors and bring them into the combustion chamber with the diesel, and I need to be able to vary that amount. And eventually I'd like to have it automated so that it works off cylinder head temperature or combustion temperature, something like that. But for right now, I just want to be able to adjust the amount of output. I think six of these should be enough output. I mean, it should be more than enough. There's more vapor coming out of one of these than I got out of my old system, and I only had 2 or 3 vaporizers in there on that system. So, and it was adequate. So I think this is going to be more than enough, which is why I think I need to use, I need to have the ability to use less vapor when needed. So, okay, so I'm going to go ahead and stop the video here, and I need to do some testing and find out if I can actually let's see if we can make this work. Get some tools here. Vaporizer keeps falling in there. Now, actually, I'm going to move that vaporizer over to number 1. Alright, so what I want to do is take this jumper, make it go from what looks to be the input over to another output. So we're going to go ahead and modify this so that it can go around. Alright. I'm going to turn it on. We got all the outputs. Now this switch is the one that changes your outputs. So, can't do it with my fingers. Let's see if I can do this with our pliers. Okay, not so simple. What I need is a couple of probes, and I'm trying to use this instead of probes. Alright, so the top side did change that. Okay. Okay. So I found out what I needed to know. All I need is a momentary switch connected to the two. Oh. Okay. The board does get hot. Ask my finger how I know that. The board does get hot. So I'm going to go ahead and shut this off for now. Alright, so let me see. Where is that heat? Alright, so the heat is coming off the back side of this IC chip. So, well, quit falling in there, would you? So this board's going to need some cooling ability, especially around that chip. I had originally thought that I could just seal this board up, pot it, is what they call that, but basically just cover this board in sealant and lock moisture out. But doesn't look like that's going to work because the heat would build up too much around this IC chip and it would melt the leads, burn up the board. It probably wouldn't last very long, so we can't do that. But now we know. I'm going to see if I can point to the outputs. Let's see, can you see? Oh, can you see? The camera's dull light. Let me see if I can zoom in on this. Alright. Try to get rid of the glare for you here. Okay, so this is our on-off button. Press one time and it comes on. Press one time, it goes off. It's momentary on-off. This is the other button. This is the other button. And you can see 1, 2, 3, 4 solder connections on it. When I jump across these two connections on this edge of the board, right on that switch, if I jump across, or basically short this between here and here, it causes it to go into the next phase. You have 7 phases. One is all on, or is it 8? I guess it's 8 phases. One is all on. One is intermittent, 3 on, and it travels back and forth. And then one is 1, 2, 3, 4, 5, 6 at one at a time. So there's 8 times before it goes back to the first phase. What else to call it? But anyway, so this is a momentary switch. It only does one action every time you push it. So you push it one time, it goes to the next phase depending on what the IC chip is set to do. And the way this works is when it comes on, the power comes on, it sets up all of them with power on at the same time. Then when this switch is pressed, it goes into the 3 in varying positions, and then it goes, when it's pressed again, it goes to 1, pressed again it goes to 2, pressed again it goes to 3, and activates each one individually until all of them are activated. So all we need to do is wire in an auxiliary switch, which is a momentary switch here, and put a jumper across there. And let's see if a jumper there would work. Yes. So as long as there's power, and I can shut it off by shorting those 2 leads. So all I'm doing is shorten those 2 leads, same thing here, and the other side doesn't matter. So we figured out our board, we know what to do, and we'll get that done on the next video. Thanks for watching. I hope you enjoyed. Maybe you learned something, maybe you did. Okay, so we're back. Now what we have right now is, let me get my pointer here. What we have right now is our circuit board, and what we're trying to do right now, I'm not worried about bypassing this on-off switch. What I'm going to be doing is adding a momentary switch to this side. so that I can operate it from here or remotely from inside the truck. So what we have is a momentary switch. You press it one time, it makes contact between the two contacts. So we'll get that out of our package here. This is a generic, made in China, on-off. It's not on-off, it's momentary. You push the button, it makes contact between these two leads. Contact, no contact. Contact, no contact. So that's momentary on. It's on or making contact between these two wires anytime you're holding the button down. So when you bump it, that's the same as bumping this switch here when it's connected to those two leads. So what we're going to do is we're going to solder this onto the board just like that, so that we have that. But I'm not going to do this directly because I can't reach this board when it's under the hood from inside the truck. That's what this is for. So what we're going to be doing is I'm going to be using a connection like this. It's just two wires and a connector. Connector slides apart. Now this connector is the smaller one. Camera has a hard time focusing on something like that. But anyway, you can see that that's smaller, this is larger, this one fits inside that one, and they snap together. And there's no lock. I mean, it holds itself together pretty well, so you don't have to worry about it falling out, but there's no lock that you have to pry a screwdriver into to unlock it. So in other words, it's easy on and off, but it makes good connection, and we can use this to remove our board if we need to. We can just unplug our wire from our remote switch, take the board out, replace the board, and put another one of these jumpers connectors on the new board, so we can do the same thing on the new board. We will have to run a jumper across, and I don't know if I'm going to do that right now, but we do need to run a jumper. For right now, I just want to be able to shut this on and off as needed. But I don't want to run a separate switch for this being used in the truck. I want it to come on when there's power and off when there's no power. So right now we need to get these wires trimmed back so that we can get the solder on here. We need to tin our connections first, and then once they're holding solder, we can go ahead and put them on the board. So we only need to be, well, a quarter or less bare. You only need to bare as much as needed to stick it to the solder. You don't want these things touching, because that won't work. So we're going to go ahead and get these in some tin or some flux so we can tin them. So you'll see there's flux on here. Both of them have flux. What that's going to do is that flux is going to help the solder attach itself to the wire. Alright, I think we might have bent that wire, so that was probably not a good way to do the flux. Yeah, that wasn't. So we'll twist that with the flux on it, and the flux will stay on it. But we want these leads to be as small as possible, so that when we go to solder these leads onto the board, we're not, because they are pretty close together and we don't want them touching each other. Okay, so that's the idea. So we're going to have our momentary switch attached to the opposite side of that connector. I'm going to use the smaller side so that when I go to put this switch in the truck, I have the smaller connector that I can push through the hole and then put this on. actually, yeah, that's right, this one goes in from this side, so that connector won't even matter. But regardless, we're going to go ahead and do it that way so that I can plug this in to the board, test it, and then we're going to add this 2-lead wire, or dual lead wire, whatever you want to call it. There's 2 wires, as you can see. It's dual lead wire. And we're going to use this as an extension between our switch and the board underneath the hood. So we'll have our connection on the board, which is this one, and then we'll have our wire connected to this, and on the other end we'll have the opposite, and that'll plug into the switch. So we're going to make an extension with this wire from the board to the switch. That's all we're doing. So the connector on the switch is going to be able to fit the connector on the board. So we're using the opposite connectors to put the switch onto the board without the extension for now, so we can test, and then we'll make up our extension so that we can unplug this from the board, plug the extension in, and put this inside the truck and plug our extension into the other connector. So everything fits together with a connector, makes it simple. Alright, so let's get started. So there's a couple things we need to do. We've already got our connector for the board ready to go. So we need to get the other side ready to go and get our switch ready to go. So we'll bare these. Get some flux on there. And then, like I did before, I just want to twist those wires so that they're combined nice and tight. Now our switch is already 10, so we shouldn't have to do anything with that. But I also, well, we're just going to go ahead and try to use it the way it is. It already comes pre-10. This is made to actually fit into a circuit board. It's hard to see there, but these will actually go into a very small opening on the circuit board. So this switch would go right onto a circuit board. But we're going to go ahead and use it, put these together, and one thing I do need to do is get some heat shrink. Let me see if I have some right here, and I do not. So we're going to pause here while I go locate some heat shrink. Okay, so we're back with heat shrink now. So I've got some heat shrink, varying sizes, and I'm going to try to use the smallest size. Color is not going to matter here. We do want to be able to cover our joint with heat shrink, so I'm going to use about that much. We're going to slide this onto the wire before we solder. That's a good fit. You don't want the heat shrink to go more than double its size when it's shrunk. So you try to find heat shrink that is going to shrink less than half of its size when you heat it up. So get this on here, run that down out of the way. So we don't want this heat shrink getting hot while we're soldering, so we want it far enough away from where we're going to be soldering so that it doesn't try to shrink around our wire, because we want to be able to pull that over our connection. Now hopefully we can make our connection good enough so that alright, so I'm thinking here, so that's why the silence. Alright, so we want to join those together. I think what I'm going to do is go ahead and bear this down a little bit further, give us a little bit more room to work with here. Even though it's probably okay where it's at, I'd like the two pieces to have a little bit more adhesion, so we need a little bit more length to put the two pieces together, like that. Well, I guess it would be nice if you could see. So we want them to overlap just like that, and then solder that together. When I do this, I'm going to need to use my alligator clips to put the wire together, or at least one side of the wire, because I can only use two hands. I only have two hands. Alright, so let me get everything set. Alright, so first thing we want to do is get our connector attached to our board, and then we can move our board and put our wires there and do some connections on the switch. So we've got both of our wires 10, not 10, we're about to 10 them, but we have flux on both of those so that they will absorb the solder once we get our iron hot. So I'm going to go ahead and turn on my iron. This is a 60-watt iron. It's a cheap one. There's different temperature, there's a temperature selector on here. You can turn it up or down. All the way up is 400 degrees Celsius, or 450 I guess. We're going to set it about 400, which should be enough. We also want to get our tip 10, so what we're going to do is we're going to go ahead and get our tip into some flux. Okay, and you can see that starting to boil, and then we want to get some solder on there while we have some flux on it. And when it gets hot enough to melt the solder, we know we're at operating temperature. We want to get solder on our tip. Now I use plenty of solder to start with until it starts to fall off. Then I wipe off the excess . Tap it, make sure, looking at it, that it's completely coated. Now we want to take that and attach the wire to the board. Now this is tricky because these are surface mount. You don't want too much heat on a surface mount because you can loosen it up. But we're doing one lug at a time. First we need to tin. We need to tin our connection. So we're going to get a little solder on our tip again. Hopefully you can see this. We're going to get some solder on the tip. We're going to go ahead and put it on the wire. And when there's solder on the iron, it actually helps heat up whatever it's touching. So if your iron's dry, it's not going to work as good as if it's wet. So all we're doing here is we're just getting solder to stick to our wire. Okay? That's nice. That's 10. And we do the other wire. We just want the solder to soak into the wire itself, which is why we use the flux, because we want that flux to help pull that solder into the wire. A little bit more heat, moving that solder up and down on the wire until we've got a good coating. We don't want too much, so we want to knock off the excess, but we want it to be nice and shiny, and that way we know that we've got a good amount of solder on there. Okay, so we'll clean our tip again, knock off excess. Next step is going to be putting the wires on the board. This is a tricky part. You have a lot more material here that you're going to be trying to attach here, and really it's hard for me to do this and for you to see it at the same time. But let me see if I can bring you in a little bit closer so that you can see what I'm doing here. This is not easy to show, so we're gonna do our best. Okay, hopefully this camera will focus. Maybe not, I don't know. Alright, we're gonna start with the first one. We're gonna heat up that lug and heat up, actually I'm gonna heat up the wire and then touch the lug and see if I can get that wire to stick to that lug. And obviously easier said than done. So I'm going to go ahead and heat up the lug, try to get that solder to flow. Alright, it's not flowing. By this point I should have already, I'm going to go ahead and get the excess off of there. Be careful, it's very hot. There's a coating on the circuit board that we need to clean off, so I'm going to go ahead and shut off my iron so it's not overheating. You don't want your iron to get too hot. You only want it to be turned on when you're using it, and then shut it off when you're not using it. You don't want to leave your iron hot. Well, leaving it hot is fine, but you don't want to leave it on while you're not using it. That builds up too much heat and you'll end up burning your iron, the tip. So we need something to clean that off. I'm going to go ahead and use a small screwdriver, and I'm just going to scrape on top of that solder and see if I can bare some of that coating. Once I have that bare, I'm going to go ahead and heat up my iron again and try to get that solder to flow. So there are other ways to do this. There's chemicals, acetone, other things that you could use. I'm just using a screwdriver. So we're going to have to turn our iron back on here, and now I don't know, it may help to have just a touch of flux on here, and then I want to see that solder flow. I want to see it move. If that solder doesn't move, we're not going to be able to make a connection. So we want that solder to move. I'm trying. I don't know if you can see. Can you? No. We got the iron right on the tab, and I'm moving the iron around, but I'm not getting any kind of movement on the solder. It's not heating up enough, and it could be because of the coating that's on there, or it's just not, the tip is just not hot enough. I'm not sure, but we'll keep trying. Alright, I'm going to try a little bit of flux on there and see if that helps eliminate some of the coating. No, it's not. Okay, then we'll go ahead and clean the tip and get a little bit of solder on there. A little dab of solder on the tip will help to heat up the other solder. So put a little ball of solder on there and try to lay that ball of solder on that tab and see if we can get the two to join by doing that. I saw smoke. Not seeing solder, so I'm going to put the solder right on the joint and see if we can make the two come together. Right where the heat is. What I need is a good glob. It's not a glob, but I need a good amount of solder there so that I can stick that wire to it. And it needs to be easily heated. So I'm just going to keep on adding solder until I see, there we go. Okay. Now I got something nice and shiny. On that one, I'm going to try to go around the other side so that my hand is not in the way. Alright, well, she's getting hot. Put a nice bit of solder on there. There we go. Okay, now she's nice and shiny. So you can see there that by adding solder to our iron, a nice little dab of solder on the end, it helps to heat up the other solder. I guess it makes more contact with the heat. Okay, so now we have that. We have our tin on our wire, and now we want to make the wire stick to the area that we just got new solder on. So once you have this hot enough, you want to stick the two parts together and then let go, let the heat dissipate. So we want this solder, there we go, to flow, and then we want that solder to flow, and then we want to put the two together. Because we're gonna need a good connection here, one that won't just fall off, and we don't want this to be too close to the other one. Those two wires have to be separated. So I'm holding this on top of the other one, heating up the wire and hoping that I'll get enough heat through the wire onto the tab. Really hard trying to make a connection like this, but we're gonna try it. All right. Okay, so gonna go back to solder on the tip again. Okay. Get a nice little bead of solder on the tip. Get that on there. Push the wire down into it while heating up the tab. Move it back and forth a little bit. See if we made our connection. Now I think we did. So you can see that we have a nice little blob over there. It's not ideal. I'll say that. When you're doing a connection like this, this is a double layer board. It's for surface mount. Through hole would not work in that spot. Well, you can see a couple of through holes right there. That wouldn't work in that spot. The board has to be designed for a through hole, and this board's not. There are no through holes there. This is a surface mount component. Ideally, we would want this wire to go through a hole. That's what a through hole is. But we don't have that ability. I'm going to go ahead and get some solder on here. Got a nice little dab of solder, and we're going to try to get this connected the same way we did the other. And get some heat in them. Not good. I'm going to do that again. Get that flowing here. And try to push it down on while it's hot. Still not good. Still not good. Okay. Still not getting a good connection, so we're going to clean off the tip again and then reapply the solder. Get a little blob on the end here, and then get that blob on the tab. At some point it will stick to the tab. Okay, we may have a connection. We'll find out. I'm going to go ahead and shut this iron off. I'm going to set this iron out of the way here. Someplace, there we go. Okay, so what we have now is two wires connected to our momentary switch with a connector. Now, I would not call that a good connection. I would call that okay, but not good. And as long as there's no tension and there's no vibration and a lot of things, this will stay attached. So for us to do our testing, it'll be fine. So we're going to go ahead and move this, and we're going to start on our wires. So we'll set this off to the side. Now we're going to get our connector set up for solder. And this one, we want our switch to be attached. So we want these wires to be attached to those wires. I'm going to go ahead and separate these, line them up as best we can, and then once we have them about where we want them, we'll go ahead and heat up our iron. And okay, so I'll do one at a time here. I've got this wire laying against this wire. There's flux on one and 10 on the other, so it should be fine. So we'll go ahead and turn on our iron. Get our solder ready. This is a 60-40 lead solder, lead, tin, silver solder. This is made for circuits, but it's a 60-40 solder. That's a good solder for doing electrical circuits. I wouldn't try to use what is it, 54, 36, whatever it is. I wouldn't try using that for electronics because you just won't get any adhesion. So when our iron get hot, we'll go ahead and get it 10. Get some solder on here. Nice fresh solder. Roll that bead around on there. And then we'll knock off the excess. Clean our tip. And we're ready for solder. So we'll go ahead and dab some on here. Get those two, there we go. Get those two together. Get some solder flowing. I'm going to put this underneath because I'm sure I'll be dropping it. Get that on top. I'm just going to flow solder into this as the heat hits it. It should absorb into this top wire. The bottom wire is already tinned. That's not the issue. This top wire is, and we may have to tin that top wire first. So, well, it tried to stick, but not good enough. Well, starting to absorb into our other wire, but like I said, it's not good enough. I don't like some adhesion. I like all of it. So let's see what we got here. Got one wire wanting to stick up. I can lay that wire down with heat. Looks like it needs more. I'm going to give it a little bit more. Yeah, I'm forcing the solder into the wire. I think on the next wire I'll go ahead and tin the wire first. So that's a pretty good adhesion. Got a little bit of a, we're a little pregnant there, so I'm going to go ahead and pull some off the high spot. That should be fine. Get rid of this little bit sticking out here. Alright, now I'm going to go ahead and tin the other wire, but first I want to go ahead and take that wire out of the way. So carefully move that out of the way and then readjust these so that they'll line up easier. Okay, now I want to go ahead and get the larger of the two wires tinned. Tinning means getting solder into the wire. That's what tinning is. And once you have a wire tinned, in other words, you have solder attached to it, then it's easier to put that wire onto another wire soldering. So solder sticks to solder way easier than it does to something that's not soldered. So we got solder on there. We'll go ahead and pull off the excess. Pull off the excess. So we have a nice even coat. And then we can take our other wire, set it on there. And this is where it kind of gets tricky, but since they're both tinned, let me see if I can reach around this way. Not quite. Well, grab some pliers here. Okay, so got that, and I'm going to go ahead and heat up the solder. Alright, looks like those are joined. Clean off the tip, shut off the power, and now we can check it out and see what kind of connection we got. Okay, so that looks pretty good. I wouldn't call it ideal, but you know, they're not going to come apart. And there's good connection, so we'll settle for that. It's not great, but it's okay. Now, if you really, if this is ever going to get tugged on, if you're ever going to have these wires trying to tug, then what you want to do is you want to bend the two pieces around each other and then solder that joint. So make a U, fold it over one, make a U, fold it over the other, twist both sides, and then tin that with flux on it, and get the solder to sit down in there. But that makes a lock joint, or it can't pull apart. Even if the solder joint gets weak, you can't pull apart because they're locked. They're entangled. All right, so I'll go ahead and pull my heat shrink down one at a time here, and I'm going to heat that up. Rotate it around. Alright, there's one. And two. So we've got a momentary switch with a plug connector on the end of it that will go right into our circuit board. Okay, now we've made our connection. Now we have a momentary switch and our circuit board. I'm going to zoom out, and then we're going to go ahead and try this out. So we're going to need our, sorry, I'm going to move the camera here. We're going to need our water. And our vaporizer, which fell in the water. Great. You're going to want that. Let me set this off to the back so it's not in our way. Now I'm only using one right now. We're just testing our circuit, so I don't need all 6 hooked up to test the circuit. Alright, so I'm going to go to the first one. Well, if you would just stay put, I'm going to go to the first one, plug it in there. Okay, maybe okay, well, I'll tell you what, why don't you just go ahead and do what you're going to do, and I'll do what I'm going to do. Okay, so we got that plugged into the first one. Anyway, we'll let that sit for a minute. It'll eventually push that water off the top, but every time it falls over in the water, it gets water on top, and it's hard for this to start up. Excuse me. So now we have our momentary switch connected to our button that allows us to switch modes. So that would be the mode switch, I guess. Alright, we're going to go ahead and plug in power. Okay, now we have power plugged in, and we're going to go ahead and turn it on. We've got activation. There we go. I mean, that really, I don't know what the volume, well, okay. You see, so when it drops down into water, water builds up on top, and it can't actually work. But once the water is gone, it will. So, there it goes. Okay, so there's a water droplet on top, and that prevents it from making the vapor. Once that water droplet is off the top, vapor. So there you are. So now let's test our switch, which we wired in, and see if our momentary switch changes the operation of our board. 1. Okay, so the first mode is switching, keeping 3 on, but moving along the board, so it's alternating output with 3 outputs. Okay, so the next mode is 1, which is this one, and then 2, 3, 4, 5. And then the last one resets back to varied output, variable. So we press again, 1, 2, 3, 4, 5. So it's working. Power off. Our switch is working. We have this board working now with a remote switch. I can take this connector apart. I can put an extension between the connector. I can make another 2 connectors, one on each side of our extension wire, which we have right here, the dual lead, and we'll have extension so that we have this switch on the dash to adjust modes on our board, and we'll be able to adjust as we're driving down the road, adjust the output from our vaporizer, so we can kind of match the air, fuel, water mixture. Okay, so next step is going to be making the extension, which I won't show. I've already shown. This is the easy part. The hard part was getting that wire to attach to a surface mount on that circuit board. That's tough. Ideally, we wouldn't want to make any modifications to this board if we could help it. But this board's going to be under the hood, so we had to make some modifications so that we can extend this out. And there's other ways to do this, but this is just the way that I did it today for testing, and this is probably how it'll run. So we'll see. More than likely that's going to be a problem later on. If I try to run this in the truck the way it is, more than likely one of those connections is going to come off. It's going to come off, crack, it'll be an issue. So we'll have to revisit that later. Alright, hope you enjoyed. Like and subscribe if you feel like it. And we'll see you on the next one. Let me get you in here real quick. That's going to fog up the camera, but you can see each of our 6 vaporizers are producing vapor. I'm going to set you back out here. Now, let me readjust. I'm sorry. I got to readjust this camera again. Anyway, so as you can see here, all 6 are lit up. Now, when I press the button without my hand in the way, it'll change to a varied output, and 3 of them will be on, and it'll just rotate through those 3 in order, and it'll continue to do that on the output. Now when I press it again, I'll go to 1. So you can see there's 1 lit up, and there's 1 producing, and then 2, and then 3, and then 4, 5, and 6. Now they're all lit up, they're all producing solid. Now that gives me the ability to change my output from the vaporizers and vary the amount of output that I'm getting in the engine. So At idle, I don't want all of them on. At idle, I might just want one of them running. Um, or maybe at idle, I have it so that it's running like it is right now, cycling through 3 at a time. So basically half the output, but it's cycling through each one. I'm not sure, but at least I have that variability now. And now that I have this cable made up, I can unplug this cable from the circuit board and replace the circuit board if needed. If I happen to burn up a circuit board, which I have a habit of, I can just swap out the circuit board by unplugging these inputs and you know, be able to change the output so that it makes it better in the truck. Anyway, so that's what we got. We got our circuit board, a switch, and actually since I made this extension, I'll be able to put this circuit board inside the truck, so there's no need for this momentary switch. So I'll be replacing this board with a new board that doesn't have any soldering done to it, and these connectors will plug right into the new board, and you know, everything will work just fine. So that's the update. The next thing we'll be doing is we'll be taking our floater with all of our vaporizers, whatever you call them, in it, and we'll be installing this in the vaporizer for the truck. So this is going to float in the water, and if I turn a corner, it will be able to swish with the water, and it'll keep these wicks in the water. I'll adjust the wick length to the water level so that these aren't holding this up. This will be resting with the float level set inside the vaporizer. So this should solve my problem with the variability in my old setup. Driving down the road, you know, water moves, the truck moves, you turn a corner, the water sloshes. So this is going to help with that. This will be able to ride the wave no matter which way I turn, and it'll continuously put out the same amount because the wick will be in the water. And you know, that's going to make this a much more stable output than my last system. So hopefully that works better. But the next step will be making the vaporizer for the truck, assembling all the pieces, getting it hooked up, and then doing some testing on the truck. The first thing I'm going to do is I'm going to go ahead and do a baseline on the truck. The truck gets about 15 miles to the gallon, so I'm going to do 60-mile circuit round trip if I can. I'm going to figure out a round trip that gets me 60 miles, and I'll duplicate that round trip. So that should be 4 gallons of fuel. I'm going to fill up the fuel tank when I start at a gas station here locally, and then I'm going to do that 60 miles, and then I'm going to come back to the same pump, same gas station. Not that that matters, but I'll be filling up the front tank on the truck, and you'll just have to take my word for it right now because I don't have a camera set up to, you know, verify everything I'm saying and all that. But I'm going to get a baseline, and then I'm going to do some testing with this once I have it installed, and I can compare those two, and I can see, you know, if there's major results, and if so, I can identify whether it's just the hydrogen and water vapor, or whether it's something else. But we'll find out, and maybe it does nothing. I won't know until I try. So maybe I'm completely wrong, but that's what we're going to find out. I'm gonna do a baseline test right now, and then when I get back, I'll start working on the vaporizer, putting that together, and then once I have all those pieces assembled and everything fits on the engine under the hood, I may have to go back to the old hood that has a cutout for the plumbing, because it is 4-inch pipe coming off. So we'll see. But I'm going to go ahead and do the baseline testing today. I'll fill it all the way up to the fill neck until it can't take any more fuel, and that's how I'll do it every time. So I'll fill up before I leave, and then I'll fill up when I get back, and then I can figure out exactly how much mileage like that. There's better ways. I don't have anything set up for auxiliary fuel tank to hook it into the fuel lines and all. I don't have all that set up. So when we start doing serious testing, I'll set something up like that so that hopefully it could be a visible tank, and we'll do more, longer tests. But for the initial testing, I'm going to do 60 miles. That's 4 gallons. So that should be enough time. Varied traffic, you're going to have stop and go, you're going to have long stretches, depending on the route that I take. But I'm going to try to make it more or less consistent driving. Not a lot of city traffic or anything like that. I'm going to take back roads, but 55, 60 miles an hour is about what that truck does anyway. So I don't want to be getting out on the highway and slowing people down. So anyway, today I'll do the baseline test. I'll video probably when I fill up and when I get back, and show the results of that so that we can have that documented to start with. And then we'll make our vaporizer, get that installed, and do another test with just the vaporizer and hydrogen, and see what we get. So stay tuned, more to come.